Hello, morning. Welcome to everybody. Today we are going to make our fifth seminar of the Advanced Cognitive System and Data Science Group at the University of Southeastern in Norway. The presentation of today is going to be done by myself. I'm Carlos Capitan, so I'm going to share the presentation with you. This one. No? Okay, the presentation, as you can see in the. Okay. No? Okay, the presentation, as you can see, is naming integration of an aircraft system in the U-space. As I told before, I'm Carlos Capitan. Right now, I'm visitor researcher at the University of Southeastern Norway. It's a place in Kongsberg. I worked at the ICEA. It is a technological center associated to the engineering school of the University of Seville in Spain. As a short biography of myself, I have been working more than 10 years in the development of innovation projects and in different field of in the industry, some renewable energies, electrical matter, also in the robotic UTM system. I have done some technical roles and also management roles in my experience, my background, and the topic of today is the PhD, the doctorate that I have been doing in my last 4 years. So let's start with the presentation. This is the outline of the presentation with 5 points, the motivation, and one pillar of the research that we did in my PhD was a regulated framework. The second pillar is a framework for UTM, and the third pillar is a methodology to solve unexpected event that can happen in new space. And at the end, we will speak about some synergies from one project and another and the future work that it came to my mind. First of all, speaking about motivation of the PhD, it is well known that the tendency of the use of UAS is huge in the last years for many commercial and civil applications. That's brought some problem with some problem to be solved in terms of regulation and in terms of restructure the urban airspace. If we speak about regulation, EASA is the regulator of the airspace in Europe. Define some risk-based categorization for U.S. operation. They define 3 types of risk of category for operation with US, specific category, a certified category, and an OPE category, depending on the risk that we have in the operation. Also, there is an entity that is joint undertaking for rulemaking on unmanned system that launch some different regulation. For example, the specific the SORA is a specific operation risk assessment. It's a risk assessment for getting the approval to fly in the use space. We were talking about this later on. In terms of restructure the urban airspace, in United States, they started to work with the UTM concept. The meaning is U.S. traffic management. They develop a huge project trying to integrate drones in the actual airspace in United States. In Europe, the entity that is promoting the development of this concept UTM is CESAR, joint undertaking. In Europe, the name of this huge project is U-Space. We are going to develop our research. All the things that I'm going to present here is in the context of U-Space. Speaking about regulatory framework for US as objective, we had the task of study and apply the regulatory framework coming from the European Commission to get the approval for US flying in the U-Space. This research was made in the context of the multi-drone project that is a European funded project, Horizon 2020. And the work that we achieved in this research, this was to make an evaluation of the risk level of an operation, that the operation is a aerial cinematographic operation to be conducted with different with autonomous small UAVs. Okay, so we applicate all the process of SORA methodology that is defined by the EASA, by JARUS, as I told before. Here we can see some pictures about the different whole the process that you have to do in order to accomplish the assessment, get the approval at the end to start flying in the use space. You need to take some mitigation action if you don't get a level of safety that it is safe in terms of the specification of SORA. We also take some learn lesson from the application of this regulation, because they don't consider multi-UAS in the regulation. They just consider that one drone, you can apply SORA just for one drone, or if you are working with a swarm of drones, they consider the swarm as one drone. So in terms of applicating SORA in a multi-UAVs operation, like in U-Space, I think that the SORA should modify and consider more multiple operations in operating. The second pillar of our research is based on the development. Well, the objective is building a framework for unmanned aerial traffic management in the context of U-Space. this research was funded, is aligned with the project, European project Horizon 2020 Gauss. That it is funded, but it was funded with GCA. The work that we achieved in this research was to develop an open source framework based in ROS as underlying middleware for a UTM system architecture. And there we developed a UTM with in-flight use-based services. In-flight services are the service that you need when the drone are already flying. Okay. Then once we develop this software architecture, we tested with defining some use cases with the US operation and running simulation in realistic simulation, one setup for multi-US operation. Here we can see some scheme of the architecture of the use space. We have in green the services that we developed in our architecture that are tracking, monitoring, emergency management, and tactical deconfliction. In green, we can see 3 blocks that are software module that we need to run the UTM system as a whole. Outside the UTM system, we have more stakeholders that they are part of the of the use-based ecosystem, as they are the drone operator, the drone itself, authorities, and so on. You can see also a link to the open source repository where all our software development is released. At the right of this slide, we can see taking into account some report from Eurocontrol, how is right now the overall implementation level in Europe of every service of use-based. As you can see, our UTM system is facing some services like tracking, monitoring, emergencies management, and tactical deconfliction that they have a big gap to be improved in terms of implementation around Europe. Also, there is a consideration in our development that we are considering 4D dimension volumes as it is defined in the CONOPS of the European project Chorus. So you can see that we consider a flight plan as a list of waypoints. We consider that every operation have a flight geometry and operational volume. The operational volume is the volume that you are supposed to do your operation when you are a drone. And it depends of the kind of drone that is flying, okay? Then in this slide, we are going to show a video about our UTM architecture system. At the right, you can see the functionality that our UTM system covers. Okay. Here we can see that we are developing UTM system to integrate in the same airspace fixed wing and rotary wing UAS. we are considering for the operational volume, as we said before, and also for the trajectory for US, considering position and time. We develop in-flight US operation, well, in-flight US-based services, and we have automated decision making during real-time threat management and conflict resolution. We define two use cases that we are going to see now. The first use case is defined by the one fixed wing drone that is doing a power line inspection operation, and one multi-rotor drone that is doing a precision agriculture operation. So the US2 started on time, but the US1 delays in operation start. So monitoring service detect that there is a loss of separation between the two drones. So tactical deconfliction service propose different options to solve this conflict, and why tactical deconfliction proposed that the multi-rotor change the trajectory, because in the rule of the airspace we consider that the fixed wing drone have more priority of not changing the trajectory, because the maneuverability of a multi-rotor is easier than a fixed wing drone. So emergency management service decide what is the most optimal solution to solve this problem. The multi-rotor, we can see that that avoid the conflict like this. The second use case that we consider is that managing a jamming attack, a geofence conflict. In this case, we have also two drones. One is a multi-rotor that is doing a forest surveilling operation, and the other one is a multi-rotor that is doing a wind turbine inspection operation. Sorry. So in some moment, that's having a jamming attack that affects to the US1. Okay, so emergency management decide to create a geofence around this drone, and this geofence is going to affect to the US2 operation. So monitoring detects that is affecting tactic conflict, and tactical deconfliction and emergency management give a solution for this US2 avoiding the geofence, as we can see. Okay, going to the third pillar of our development in this topic is the objective is to build a real-time decision-making method to manage unexpected events or threats, which can happen when several US are flying in the US space. In this case, we have done, well, again, this work have been funded and aligned with the Project Gauss, as they were before. Um, um, in this case, we have developed the method. We have validated by simulation, and also we have validated in field trial with real drones. Okay. In this figure, in this scheme, we can see here see here the different threats that we are considered. They are generic threats like a lack of battery, a jamming attack, a GFN conflict, and so on. The method is implemented in the previous UTM system that we developed, specifically in the emergency management and tactical deconfliction services, and there are different or possible action to take when some conflicts happen that you can see in this scheme the three type of action, and you have some restriction in the use space or constraint to take into account. The tactical deconfliction role is to compute all the alternative flight plan that can happen when a conflict appears. For example, we consider these different in table 3. We can see different maneuvers that we consider to propose alternative flight plans. So tactical deconfliction consider all these kind of maneuvers and calculate different metrics in order to give to the emergency management all the metrics of every maneuver, and emergency management decision-making method have to decide what is the optimal solution for the safety and the efficiency of the operations. As I told before, we validate our methodology of threat management method in simulation and also in experiment at Atlas, that is placed in Villagarrillo, Jaén. It's a segregated airspace for U.S. operations. So we can see here a video about the result of our experiment in there. As overview, as I told before, we identify and classify generative threats in use space. We developed our method to handle this threat, taking as a base our in-flight use space UTM architecture, specifically emergency management and tactical deconfliction services. And we make automatically decision making in real time when the UTM is running. We put automatic decision making because at the end, for regularity restriction, the pilot have the ultimate decision of accepting an alternative flight plan or not. Also, in this method, we are considering four-dimensional trajectories and volumes, and we define 3 use cases to prove our concepts. The use case 1 is a violation of the safety distance between 2 operations. The first operation is a fixed wing US that start on time. And the second operation is an US that start with some delay. It's a multi-rotor. So due to the delay, some conflict appear between them. There is a violation of the safety distance. So then tactical deconfliction and emergency management propose the optimal solution to avoid this conflict. Then in the second use case, we have a operation of a wind turbine inspection operation with a drone that suffered a jamming attack. Well, sorry, it's notified a wildfire close to this drone. Okay, so a geofence is going to be created. There are two possibilities in this use case to solve this conflict is to land in one of these landing spots. So tactical deconfliction and emergency management have to decide what is the best option. Okay. We can see how the drone leaves the geofence. In this use case, there is a jamming attack to the multirotor and the fixed wing that is doing a operation a high altitude, avoid the geofence created by the UTM system. So as a summary, we were presenting the outcomes of the Gauss project and how in this slide I'm trying to show how the knowledge that we got from the Gauss project are transferred to the USEPE project. USEPE project is a urban separation management. Well, the name the USEPE project is use space separation in Europe is the name of the project. So in this project, it's defined a new concept of operation approach that it is called dynamic density corridor concept. It's a new concept of operation trying to simplify how to operate in densely populated areas as cities with multiple drones. Secondly, in this project, USEPE project, we are integrating some. Well, we are using an ATM open source ATM simulator as it is Blue Sky, and we are doing simulation with this ATM Blue Sky simulator. The thing is that right now the European Commission is promoting to develop or digitalize the ATM systems. So now that we have developing Gauss project at UTM, and different functionalities in terms of UTM, it could be very interesting to integrate some open source ATM simulator as is Blue Sky with the new functionalities that we are developed in the UTM, or try to integrate both systems. Okay, and the third topic that we developed in the Giuseppe project here in the USA is the machine learning algorithm for contributing to a safer use space. With the machine learning approach, we can calculate if there is some trajectories that they are more safer or not, and we can give some support to the operator to know if the some trajectory are more prone to be conflicted or not. So you can give some functionalities in the strategic phase of the operation and in the in-flight phase of the operations. So as a future work, I well, I consider that the problem of that we are facing with the integration of drone, it's some problem with that it could be some technologies as big data computation, because we are going to have a lot of drones flying. We will need different data sources, and we will need also real-time data processing to work in real time. And there are also missing gap in the regulation that it's doing risk assessment in real time using use space services. Because as far as I know, today we have the SOAR at the regulatory, but we need to assess the risk in real time operation while the drone are doing the operations. So I would like to thank you for your attention. I put here my contact on LinkedIn in case that you want to give me some feedback or ask some question. So I will very pleased to answer you. That's all from my side. I don't know if there is someone that can make any question. No question. No sé si está Ángel por ahí.